Hello. I'm audible. Hello.
Yes, you're
Mr.
audible.
You are audible.
Okay. Isn't
You can start.
again, please. Is the isn't clear?
X11, noise is there from your side.
Not really, ma'am.
There is noise from your side. Can you check it?
Ma'am, yes, ma'am. Sure, ma'am. Once again, ma'am.
Hello. Hello.
Yes,
Yes. Is the screen is visible or not?
the screen is visible.
No, you then.
Okay, thank you. Thiru, check your connection, the internet connection.
Yeah. Then the screen is not visible to me.
It's visible. Yes, proceed it.
Ma'am, but I can't see.
But noise is there from somebody. We could not find it out.
I think network issue.
You then, Nadaraja, is this?
Yes.
You please unmute your device. Yeah, noise is there. You unmute your device. Mute it.
Hello, ma'am.
Mute it. Mute your device. Yeah, noise is there from your side.
Ma'am, I think some network issues.
No.
I can't
Noise is
see the
there.
PPT.
See, you have to check. You have to check the net connections. Here we can see the PPT. You check your side net connections. How is it? If you are okay, can start. We are seeing the PPT. You can proceed.
Tirupugal, are you there? Ma'am, he is waiting, ma'am. Just admit him. Hello, ma'am.
You check whether he has joined now.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. I have joined. So, good morning, all. I'm Thirupugalvan, and my friend Yudan. We are from Power Engineering College, and we are going to present the survey report on the remote sensing in disaster management. Now, generally, remote sensing is an technology which we can detect and analyze the information of a place or a things or some phenomena without making a physical contact with them. So next. Kisan.
Yes, Thiru.
Go to the next slide.
Is it visible now?
It's on the first slide. Yeah.
Now is it visible?
Yeah. So we conduct a study that how remote sensing is very useful in disaster management. So we are going to see that introduction about remote sensing and components in that, and what is disaster management and the role of remote sensing in the disaster management, and the scope, what we going to see, and a survey. Next. So in introduction, so generally we can able to capture the image of the earth with higher resolution. So for that we are going to remote sensing, and especially satellite remote sensing. So using satellite remote sensing, we can cover the entire earth. So we can easily analyze the spatial data and geomorphological places in the earth using the images. So remote sensing is an art and science in which we can detect and monitor the objects, things, or place, or living things, or even a phenomena without making a physical contact with them. So without physical contact, we can be able to capture the image of particular things. So in this remote sensing I used in various applications like agriculture, in deforestation management, and air pollution, land pollution, like that. So many applications are being used in this remote sensing. So next. So the components in the remote sensing. So while we capture the image of the earth using the satellite, we can analyze those images through various methods. One of the example is ArcGIS, which is one of the software used to analyze the images of the Earth. We can analyze the high resolution images. For example, if we take the vegetation of a particular area, for only with the high resolution image, we can get the more information in that place. So high resolution image is better to get informations. So remote sensing with ArcGIS, some of the various softwares are available to monitor and collect the data, like QGIS. These are the geospatial softwares. One of the image processing softwares are MATLAB. Through MATLAB, we can process the image of the Earth, and MATLAB and ILWIS. These are the softwares we can process the images, and we can give the exact information for the particular applications. So remote sensing with ArcGIS, we can quickly manage and create the data from multiple sources, formats and projections, and can be used on any device and anywhere. So one of the natural remote sensor is our eye. So we can sense and analyze the particular place or things without a physical context. So it is one of the examples for natural remote sensor, or otherwise called organic sensor. So inorganic sensor. So it is an artificial sensor. So it is classified as framing and scanning. So framing contains cameras and video cons. Like our phones. So in our phones we have the camera. So we capture a place or an object or an human beings without making the contact. So it is an example for artificial sensor. So like that, remote sensing sensor also available, which has more resolution. So we can get an high information of the Earth. So another one is the ideal source. Ideal source contain constant intensity with for all wavelength, and then ideal sensor. So in that it contains different intensity for different wavelength. So these are the general components of the remote sensing. Next. So this remote sensing technology speeds up and simplifies the map production with built-in tools to extract accurate 2D and 3D measurements. So using this tools like QGIS, ArcGIS, we can create a map. For example, if in Uttarakhand, floods are happen often. So we can capture the image using remote sensing. So if we capture the image, we must analyze the raster information to know whether how many places are covered by the flood. So we can capture the image, and using this softwares, we can create the 2D and 3 3D image to get the exact information for the particular place. So rapid analysis with seamless access to imagery, raster, and geospatial tools. So it converts complex data to clarity in minutes and not days. So so this technology converts that image with high pixels, which is called high resolution. So while it captures the image, it is in the form of binary numbers. For all colors, I have binary numbers from 0 to 255. So with the based upon the intensity values, the binary values may change for a particular pixels. For each pixels, different binary numbers are there. So next. Disaster management. Nowadays, in the world, Corona, it is one of the disaster. Our world is now facing a lot disaster to so now disaster management means we can sorry, I disaster is a situation in which the community is incapable of coping. It is a natural or human caused event which causes intense negative impacts. So disaster is a situation we cannot avoid that. So in that situation, how we are going to manage that that situation. So that's we are saying that disaster management. The disaster may be due to natural or man-made. Natural like floods, tsunamis, cyclone, earthquake, lots of that. Man-made disasters are called pollutions, deforestation, like that. So management of the disaster is defined as the discipline and profession of applying science, technology, planning, and management to deal with extreme events. So management of the disaster. So management means we could plan and manage the situation by applying the science and technology. Few phases are in the management. They are planning, mitigation, preparedness, response, and recovery. So by using remote sensing, we can handle this disaster management by taking the image of the particular area. Like if there is a flood, so how many areas are covered by floods, or how long the earthquake affects the places. So these are all easily analyzed using remote sensing. So next slide will be continued by you then.
Thank you, Thiru. Then we are moving it. Is it audible now?
Yes, Yudan.
Is it visible the screen?
Yes, it is visible.
Okay, Thiru. Then we are moving into remote sensing role in disaster management. Okay, Thiru already said the phases of the remote sensing. What are they? Planning, mitigation, and preparedness, response, and recovery. Okay, these phases are involving in the role of remote sensing. How they are involving means planning. Which is useful in helping with forward planning. Okay, which is provides the information and the framework for planners and disaster managers to view spatial data by way of computer based maps. Okay, by these maps only we can collect the data of the disaster place. Then next one is mitigation. Okay, it is for representing the high risk areas. Where are the disaster risk at the very high level. Okay, then which are very helpful to facilitate the implementation of necessary mechanism to lessen the impact of the people who are all getting the impact by these disasters. For them we have to facilitate some implementations. Okay, for that only we are applying this remote sensing. Okay, then preparedness. This is for identification of emergency areas and positions of related departments, agencies, and human resources. And this is to make easier for security and shelters providers to plan the strategies. Okay, by this preparedness of remote sensing, we can prepare ourselves to provide the plans to save the peoples and facilitate them. Then next one is response. It provides accurate information on exact location of an emergency situation and time saving during the determination of trouble areas. Okay, it is mainly for the quick response. It is used as a floor guide for evacuation routes. Okay, these are the phases in remote sensing for the role of disaster management. Is it visible? The next slide. Excuse me, is it visible? The next slide.
No, it is stuck at role of remote sensing in disaster
Okay,
management.
thank you. Okay. Next, GIS and data. The GIS is taking a main part in remote sensing, which is mainly for the information source. The data required for disaster management is coming from different scientific disciplines and should be integrated. Data integration is one of the strongest points of GIS. In general, the following types of data are required for the data collection to analyze the disaster. Okay, what are the data are there? They are the data on disaster phenomena. Example for landslides, flood, earthquakes. The location, frequency, and magnitude of the disaster can be identified and analyzed. Then the data on the environment in which the disastrous events might take place. Topography, geology, geomorphology, soils, hydrology, land use, vegetation, etc. By using these data, we can analyze the disaster from which field we can conclude. Then the next data on the elements that might be destroyed if the event takes place.
Excuse me, participant. You have crossed more than 10 minutes. You can move fast and wind up your presentation.
Okay, ma'am.
1 minute grace time is given for you.
Okay, ma'am. Thank you, ma'am. Then the role of remote sensing in the cyclone, flood, and drought. These are the things we are seeing now. In this cyclone, through this cyclone, we can modeling vulnerability analysis. Okay, by these analysis, we can long range climate modeling. Through this, we can prepare ourselves to the people to get prepared for the impact. Okay, we can get the impact assessment and cyclone monitoring through this GIS and remote sensing part. By these technologies only, we are now we are seeing the precautions for flood, cyclones, and drought also. Okay. Then likewise, the cyclone and the drought is also the drought is also the same. Likewise, in this drought, how we are sensing the data and collecting the data from the earth. We are collecting the data from the earth, which is covered by the which is covered by sensing the color of the leaves in the earth. Okay, we can sense the 2D and 3D objects by the colors. Okay, by the colors only we are sensing the condition of the drought, which is high or low or in the medium. Okay. Then role of RS in earthquake. In this earthquake, we are planning the routes for search and rescue the people and damage assessment, which is more important after the earthquake. We are needing a lot of information about where are the damages are occurred and how the people can relieve from those places and how we can rescue them. These are the things which is covered by the role of remote sensing. Okay, then after the which are the images before the disaster, then after the disaster covered by the remote sensing and GIS. The informations are collected by the GIS, and using the remote sensing we can predict the exact locations and what we have do next. These are the things have been done. Then what are the scopes? The Earth data can be including airborne and spaceborne sensors from several countries worldwide, which provide a massive data varying in input dimensions. By using the advanced method in the remote sensing, we are in the past days we were using the MATLAB software. In nowadays we are using the deep learning and machine learning image processing softwares for analyzing the data from the GIS. Okay. Likewise, by using the advanced method of synthetic aperture radar and light detection and ranging the radar, we can get extensive opportunities in the monitoring and natural sustainability. By using hyperspectral remote sensing, we can get the high resolution images from the GIS. Okay, by using these high resolution images, we can exactly predict the exact location of the disastered place. Okay, these are the scopes. Now we are having.
Your time over. Can you show your output, please? You show your paper output.
Hello, ma'am.
You show your output.
Yes, ma'am. These are the outputs, ma'am.
What is the
text?
Is it audible now?
Yes, ma'am.
Can you say the location where you have focused to sense? Am I audible?
Hello, ma'am. Yes, ma'am.
Ma'am, we take a survey report only, ma'am.
What is the source where you have collected this image then?
Sorry, ma'am.
What is the source of this image?
Through NRSC images, ma'am. Through NRSC website, ma'am.
How many images you have collected from there?
Ma'am, we have collected the drought places and floods and earthquake.
So only 3 images you have taken as sample.
Yes, ma'am.
So from that image, what you have done?
We done the survey report with high resolution in informations, ma'am. Like using the hyperspectral data, we get that exact information of the places where the cyclone held and the flood, how many areas are covered by the flood, like that, ma'am.
So you have taken only 3 images, one for earthquake, one for cyclone, and one for indicating your rainfall condition.
Flood.
Flood.
Yes, ma'am.
Okay. So in that, have you in which image you have identified these 3 things? Whether there is a proof that you have identified these 3 things in your images?
Yes, ma'am. Then
Yes, Thiru.
Next slide, please. Yeah, ma'am. Ma'am, in this image, it shows that before disaster and after the disaster. So
here the image has no labels.
you...
Which one is the input image, which one is the deducted image, and what you have deducted from that input image, nothing is here.
Ma'am, from in left side image, it is input that is the place the place before the disaster, ma'am.
Your audio is breaking. Your audio is breaking. Can someone convey this message?
Yes, ma'am. The left side image is before the earthquake, and right side one is after the earthquake. We are taking these images and using in normalize using the MATLAB software. We are analyzing these pictures for getting the resolution, ma'am.
So can you say how you are saying that this second image, it is an affected image? This is an earthquake image you are saying. Can you say how you are saying that? Whether there is any proof to validate your result?
Ma'am, for now we are getting the affected image from the NRSA source, ma'am. So
what is the purpose of your work? What is your work then? You have taken an input image, which is a clear image, and you have taken the affected image and you are displaying it here. What is your work then?
Ma'am, we have analyzed it like this, ma'am, for earthquake and drought, the colored locations.
Okay.
Yes, ma'am.
That we accept that are all the theoretical data. What is the practical proof that this is what is the one you are showing here as an affected image? How we can accept that it is an affected image? Who will validate that? You can get any image and you can circle over that and you can say that this is an image which is being affected either by earthquake or by flood or by cyclone. But which one is true? How you can validate your accuracy?
Yes, ma'am. We didn't attach that one, ma'am. of the software image.
Have you processed your input image?
Yes, ma'am.
What is
We
the
have
size of your input image?
230 into 50, ma'am.
230 into 50.
Yes, ma'am.
Have you resized it? Have you did any processing on your image?
No, ma'am. We didn't take any extra process like resizing, gray color converting. We didn't make any process. We just analyzed that.
Whether the image you have taken is a 2D or 3D image?
2D images only, ma'am.
And how you are doing mapping of your input image of pixel value to that MATLAB coding? How you have done mapping? You have told that you have done mapping.
Yes,
How you
ma'am.
have done that? How you have done that mapping? How you have identified here this is the portion where that draft has affected or cyclone has affected? What is the condition? Which condition you have kept as a threshold to deduct this? Okay, thank you. Are there any queries? Is there, if anybody want to ask questions, you can ask. Nandini, you can process it.
Yes, ma'am. Could you please turn on your video so that we could capture the moment? Tirupugalvan and the other one, could you please turn on your video? Tirupugalvan, please turn on your video.
Ma'am, I enabled the camera, ma'am.
But you're not visible.
Ma'am, I think some network issues.
Yes, that's okay. Thank you, Tirupugalvan and the team. Now I call upon Arun Kumar M and his batchmates from Sri Rajarajan College of Engineering and Technology to present the paper. Ma'am, they are not available, ma'am.
You check and the participants list and call Nandini.
Yes, ma'am. Now I heartily invite Kokila Devi K and her teammates from K.S. Rangasamy College of Technology to present the paper.
Participant, what are you doing there? You can proceed. Santosh, Vivipriya. Who is here? Ritana Mugilan. Who has shared the screen now?
Ma'am, Vivipriya has shared the screen, ma'am.
Okay. Vivipriya.
Good morning, everyone.
The time it's 12:03. You have to complete it within 10 minutes.
Okay, ma'am. Our topic is machine learning for glaucoma assessment using fundus image. We are coming from K.S. Rangaswamy College of Technology. My batchmates are Mugilan, Santosh T, and Vivipriya. Next slide. Abstract. We have taken up the topic of glaucoma. Glaucoma is eye disease that affects the optic nerve. We are finding this disease based on the CDR ratio. We have used SSDC-GAN algorithm for finding this disease, and also we have used SVM classifier for SVM algorithm for comparing our accuracy. Next. Methodology. First, we are giving our input image. Then we are pre-processing our image and finding the optic disc and optic cup, and we are going for feature extraction, and finally we are using a algorithm. Next. Image enhancement. It is a sub-area of image processing. It is a procedure for improving the quality and information content of the original data before processing. Commonly, it includes contrast enhancement, spatial filtering, density. The principal objective of the image enhancement technique is to process an image so that the result is more suitable than the original image for a specific application. Detection of optic cup and optic disc. There are two things for detecting the optic disc. First is color component analysis, and second is the morphological operation. Color component analysis means red, blue, green are the basic components of the colored image. It is noticed that the optic disc can be extracted from the red component of the image. Next, the morphological operation. It is a process in which the images are processed based on the shapes. Here, each and every pixels of the resulting image is compared with the relating pixels in the neighboring image. Two morphological operations are applied in our project. One is dilation and another one is erosion. Dilation means enlarging our pixels by enlarging our image by adding the pixels to the object boundaries. Next is erosion. Erosion means eradicating the unwanted pixels to create a desired shape. And for optic cup extraction, a brighter portion in the optic disc is extracted from the green component of the RGB image. Here also two operations are performed. One is opening and another one is closing. Opening is the erosion that is done after the dilation, and closing is the dilation that is done after the erosion. In opening, this is used to segregate the objects. The closing operation is used to fill the holes and smoothing the object on focus. Next will be continued by Mugilan.
Please, Priya, you check the availability of your batchmates.
Ma'am, Mukilan's mic is not working, ma'am.
Then ask your other batchmate to continue.
Yes, ma'am. Feature extraction. The extraction of the attributes aims to describe the image according to the extracted features. Depending on the purpose of the problem, feature extraction can return the different features to the same image. In this work, we used a gray level co-occurrence matrix to the extraction of the texture feature in different color models. Contrast, correlation, energy, homogeneity were calculated for this image. Classification. After the feature extraction, it is not possible to predict if an image has a glaucoma or not. It is necessary to classify the image. In this classification, we used two algorithms called SSDCGAN and SVM classifier. SSDCGAN. For this work, a class of CNN called DCGAN that are based on the adversarial strategy was used. This was the output from the SSDCGAN algorithm. This is the input image, and we extracted the cup from the given retinal image using the dilation process. This was the extracted disk image. This was detected a boundary of the retina. This image was the segmented disk image and the boundary and the cup boundary image. In this, the OD region is clearly visible and it is used for further OD and OC extraction. The morphological functions with this optic disc is now applied to the algorithm. This was the real image versus the SSDCGAN image. This image is obtained by extracting the Hawk features in the image, and we are resizing the image to find a CDR ratio. This shows the level of glaucoma which was classified by our algorithm. Next, the comparison with the SVM classifier. Support, we have used SVM classifier supervised learning model for classifying normal fundus image from glaucoma affected image. Is the machine learning algorithm that analyzes data for classification. This image shows the segmented optic disc and optic cup of the SVM classifier algorithm. This is the OD region which came after iteration process. This is the final segmented optic disc. This image was the after 60 iteration. It is obtained by a transformation function. This was obtained by decreasing the threshold value, and this is the classified image, whether this image is a glaucoma image or not. In this, we have given many contributions for this algorithm to detect optic disc, optic cup, and glaucoma assessment from the given input image. When the ratio of the CDR exceeds 0.3, then it is referred to an glaucoma eye. Then it's below 0.3, then it's a non-glaucoma. This is the accuracy we have compared. Thank you.
Okay, is it audible now?
Yes, ma'am, you're audible, ma'am.
So you have identified the affected portions of your eye image.
Yes, ma'am.
And you have mentioned that this is as a glaucoma.
Yes, ma'am.
Whether any other diseases are there for this fundus image or only this is that alone.
Ma'am, diabetic retinopathy is
So only maximum 2 diseases will be there in that affected image.
மேம் நோ மேம் நாங்க எடுத்த இன்புட் இமேஜ்ல வந்து குளுக்கோமா டிசீஸ் இருக்கு மேம். இன்னொரு டிசீஸ் வந்து ஐல அஃபெக்ட் ஆகுது மேம்.
So what are all the diseases which affects your eye? Can you list out the diseases?
Glaucoma, diabetic retinopathy,
Other than that,
cataract, ma'am.
so how many images you have collected for each disease?
Ma'am, for glaucoma, we collected more than 10,000 images, ma'am. In this, we used 200 images for classification, ma'am. In the 200, we took a single image.
For the remaining 2 diseases, how many images you have collected?
மேம் நாங்க அந்த டிசீஸ் கண்டுபிடிக்கல மேம். கிளைகோமாக்கு மட்டும் தான் மேம் கண்டுபிடிச்சோம்.
So in classifications, what you are giving the results finally? This image is a affected glaucoma affected image or it is a pure image? Is it so?
எஸ் மேம். நார்மல் இமேஜா இல்ல டிசீஸ் அஃபெக்ட் ஆயிருக்க இமேஜா?
Okay, how many images you have used for training your classifier and how many things you have used for testing your classification output?
மேம் 40 images.
40 images you have used for? So you are not clear in that.
3. Yes, ma'am.
Have you trained your network for this SPM classifier?
Yes, ma'am.
Okay, what is the range of that glaucoma level you have fixed? Have you have identified that region as affected with that particular disease or not? What is the threshold you have fixed?
மேம் greater than 0.3னா டிசீஸ் அஃபெக்ட் ஆயிருக்கிறது மேம். லெஸ் தேன்னா நார்மல்.
So what is that 0.3 value indicate? What is that CDR?
Cup to disc ratio, ma'am.
So what does that 0.3 indicate? Can you explain it more clearly? Why it is fixed as 0.3? Why not it can be 0.1 or it can be 0.5, right? Why you are not choosing 0.1 or 0.5? Why you are strict to 0.3? What is the reason?
That is the normal value, ma'am. Normal value of the eye. That CDR value, ma'am. Normal ஐயோட CDR value அவ்வளவுதான் மேம் இருக்கும்.
But how you are fixing that? If once it is affected, whether that is that disc to cup ratio, whether it gets changed?
Yes, ma'am, it will change.
So what is that CDR ratio of your image? What you have deducted it as an affected image? What is the CDR value of your analyzed image?
Zero 0.7, ma'am.
So once if it is greater than 0.3, any image, if you are having the value of greater than 0.3, you are saying it is an affected image. Is that right?
Yes, ma'am.
Yes, ma'am.
Can you show that glaucoma level of your identified image? Have you calculated it? You are saying it is 0.7. You will show your calculation. How you have calculated it in your MATLAB?
Ma'am, we have not taken a screenshot of that, ma'am.
So what is that formula? How you have used it? Any answer for this?
மேம் டிஸ்கோட ஏரியா டயாமீட்டர்லாம் வச்சு கண்டுபிடிச்சிருக்கோம் மேம்.
So you tell that value. How that? What is that disk value of a normal eye? What is the cup value of a normal eye? And what is the value which gets changed in this affected image? You just tell it orally. Okay. Okay, thank you. Thank you. MOC.
Vivipriya and the team, kindly switch on your video so that we could capture it. The other two members, kindly switch on your video. Thank you. I cordially invite Dr. P. Babu and his team from K.S. Rangasamy College of Technology to present the paper.
My screen is visible. Is that
It is visible.
Yogaraj?
Hi, ma'am. Hi, friends. Myself, S. Yogaraj. My teammates Ram Kishore, Tirumurti, Ranjit Kumar. We are coming from KSRCT. Our topic EMG signal based game controller. Objective. The EMG based game control for rehabilitation to develop an EMG based game to develop for handicaps who have no hands, then to help a game to play. To make an assistive device for impaired patients and identify move time with an electromyography signals and also playing for the game. Abstract. A human computer interface system using EMG signal to design a computer-based game control that enhance your muscle strength and can be used for rehabilitation of muscles. Disability in stroke service is largely attributed to damaged neural pathway, which result in a improper activation of muscles to encouraging modulation of activation levels and exploration of activation levels or workspace. Yeah, developed a platform for playing game growth. EMG signal not only for an clinical usage and also for gaming and entertainment usage. Electro means electrical activity. Myo means and signals. Extra.
System development, EMG signal acquisition and leg movement, mapping, extraction of EMG signal, next result playing the game. The intent of the system is to increase the exploration of the leg activation workspace. The user must manipulate EMG signals to control the position of the cursor on the computer screen in order to play games. In the exiting work, the puzzle game is controlled by using EMG sensor only is two direction and used in MATLAB. But in our project, we are using two sensors and two different softwares. That sensor and softwares are gyro sensor, and the software are Arduino and joystick programming software. Using this sensor, it will access 6 directions, and we also using card game in this project. In this game are having 6 movements. There are left, right, up, down, start and stop. Leg activation is estimated in real time from filtered EMG signal. At each time point, the normalized EMG activation is projected to on the target PC on movement. The location within the mapped to the corresponding locations on the computer screen. EMG signals are used to control a signal cursor. A variable relative weighting is applied to the EMG mapping from each extremity to compute the final movement. Ultimately used to control in this game is controlled by using leg or hand.
Next block diagram. This is our project block diagram. In this block diagram, we are connecting two sensors like ENG and gyro sensors. There are the electrodes and gyros. Excuse. The electrodes and the gyro are connected to the body. The electrodes is measuring muscles response or electric activity from the body. The gyro sensor is also known as angular rate of sensor or angular velocity sensor, or the device is sensing the angular velocity. The angular velocity in the terms of angular velocity change in a rotational angle per unit time. The electromyography and gyro sensors are connected to the Arduino. The Arduino is interfacing with the interfacing between the sensors and computer. Next, if the in this the electrodes are connected to the body, when we are moving, our hand is left or right, means the game is controlling by the our movement of the body, like left and right. Moving means the car is moving to left and right. Next, this is output. Kishore?
This is our output. We can connect electrodes with interfacing with human body. Electrodes can analyze EMG signal from human muscle activation. Then gyro sensor will connect to other side. The gyro sensor 4 movements go on the left, right, straight down. Then muscle activation means two bidirectional movements, 0, 1. We can control the game in this picture. Next one. Conclusion. Most of the physical challenge people suffer a lot of problems in playing. Their needs, though, proposed an electromyography signal based physical impaired with assistive tech, and we have using the handicap peoples also use control the game.
Thank you, ma'am.
Guys, how far you have gone with your project? Have you completed your project?
Yes, I
Yes, ma'am.
Yes, ma'am.
Okay. What is the cost of your gyro sensor?
1,200 something, ma'am.
And myo sensor?
Ma'am, myo sensor ma'am 1,200. Gyro sensor 1,000 something.
Okay, so you have shown up to the thing that you have connected your sensors, and with this connection and directions, you are controlling your game. Do you build your game on yourself?
Game is an online game.
Oh,
We are using to program joystick programming software for controlling the game from Arduino to connecting to the Arduino and joystick program.
yeah. Why you have chosen Arduino software? Is there any other alternatives?
மேம் EMG சிக்னல் வந்துட்டு நாம வந்துட்டு பேசிக்கலி வந்து 2 மூவ்மெண்ட்ஸ் தான் மேம் யூஸ் பண்ண முடியும். Arduino சாஃப்ட்வேர் வந்துட்டு நாம வந்துட்டு அனதர் மூவ்மெண்ட்டுக்காக EMG சிக்னலை வந்து மாத்துறதுக்கும் போது வந்துட்டு மற்ற மைக்ரோ கண்ட்ரோல்லாம் போட்டோம்னா ஃபுல்லா வந்து இது சேஞ்ச் பண்ணணும் மேம் ப்ரோக்ராமிங்ல. ஸோ அதுக்காக கொஞ்சம் சிம்பிளா இருக்கணுங்கிறதுக்காக வந்துட்டு Arduino யூஸ் பண்ணோம் மேம்.
Okay. And நீங்க first காமிக்கும்போது it was with the leg, right? Now
ma'am.
in your picture you are using hand.
Ma'am, our project can both leg and hand, ma'am. எங்களுக்கு வந்து ஹேண்ட்ல மட்டும்தான் மேம் வந்து கொஞ்சம் எக்ஸாக்ட் அவுட்புட் கிடைச்சிருக்கு. லெக்ல வந்து அக்யூரேட்டா வரல மேம்.
Yeah, did you analyze what was the reason behind it?
மேம் ஹேண்ட்ல வந்துட்டு மசில் ஆக்டிவேஷன் வந்து அதிகமா இருக்கங்காட்டி வந்துட்டு நம்ம மசில் ஆக்டிவேஷன் ஃப்ரீக்வன்சி வந்துட்டு நார்மலா வந்துட்டு 100 ஹெர்ட்ஸ் வரைக்கும் 100 to 150 ஹெர்ட்ஸ் வரைக்கும் கிடைக்கும் மேம்.
Oh. Okay then. My question is over.
Can you control your game for full 360 degrees?
Ma'am?
Can you able to control your game?
Yes, ma'am. Only control with the hand movements, ma'am.
Okay. Even
from left to right, ma'am, or back or forward, ma'am, like this, ma'am.
So you could not change it even for 180 degrees.
It will possible. I don't know, ma'am. In 90 degrees possible, ma'am. 90 degree or 180 degree also possible. Means 90 degree change பண்ணோம்னா மாறும், ma'am.
Have you checked it practically?
மேம் ப்ராக்டிக்கலா செக் பண்ணும்போது எங்களுக்கு வந்து எக்ஸாக்ட் அவுட்புட் கிடைக்கல மேம்.
You troubleshoot and have that.
Ma'am?
Troubleshoot your hardware and the updation and have it. Okay?
Okay, ma'am.
Okay, ma'am.
Okay. Thank you.
Thank you.
Excuse me, I have an just now I got it out. So what is the delay in your what to say or a deviation delay with your regular joystick and your all these sensors and electrodes? Is there any delay because you are using it with the hand, but in normal we are using with some joysticks? So is there any delay with that?
மேம் ஜாய்ஸ்டிக் வந்து யூஸ் பண்ணும்போது வந்துட்டு நான் வந்து ஈஸியா கண்ட்ரோல் பண்ற மாதிரி இருக்கும். நான் வந்து ஹேண்ட் மூலியமா பண்ணும்போது வந்துட்டு அந்த மூவ்மெண்ட் எல்லாம் கொஞ்சம் டக்கு டக்குன்னு கொஞ்சம் ஃபாஸ்டா சேஞ்சஸ் ஆகும் மேம். அது ஒண்ணுதான் மேம் டிராபேக்ல வரும். மத்தபடி
எந்த மூமெண்ட்
மேம் இப்போ நான் வந்து ஜாய்ஸ்டிக் வச்சு கண்ட்ரோல் பண்ணும்போது லெஃப்ட் ரைட் டவுன் அது வந்துட்டு நம்ம அந்த கீ பிரஸ் பண்ணும்போது வந்துட்டு நம்ம கரெக்டா கண்ட்ரோல் ஆகும் மேம். மேம்
சொல்லுங்க.
இப்போ வந்துட்டு நம்ம வந்து அதுவே ஹேண்ட்ல வந்துட்டு அந்த கைரோ சென்சார் ஃபிக்ஸ் பண்ணி இது பண்ணும்போது வந்து அந்த ஹேண்ட் வந்து ஒரே மூவ்மெண்ட்ல இருக்கணும் மேம். அப்பதான் வந்துட்டு கரெக்டான வேல போகும் மேம். இல்ல வந்து நம்ம கொஞ்சம் இது பண்ணா கூட வந்துட்டு அந்த வேவ் வந்து மாறதுக்கான சான்சஸ் நிறைய இருக்கு மேம்.
ஓகே, thank you.
Thank you.
Tirumurthy and the team, could you please turn on your video? Tirumurthy, kindly turn on your video.
Ma'am, I am on, but not visible, ma'am. I don't know what's the problem.
Okay.
Okay, thank you, ma'am.
Yes, thank you. Now I invite Vanita K and her batchmates from K.S. Rangasamy College of Technology to present the paper.
Our topic is development of effective machine learning model to forecast vehicle crash caused by weather condition. Usha?
Okay, sir. Maybe next slide. Hi everyone, good afternoon. Abstract. The project is about prediction of vehicle crash due to climate conditions like rain, sunny, fog, etc. Here used the LSTM. LSTM means long short-term memory algorithm for time series analyzer. Proposed methodology. First, we are collecting the history of CSV file on crash due to weather conditions. Then normalizing the data and implementing the algorithm and module evaluation at last predicting the crash due to rain and sunny conditions. Next presenter will Tamil Moli.
Hello everyone. Good afternoon all. Vivi, next slide po. Data visualization. Here we have visualized the data, the actual data set, which is the input data we have taken. The input data collected for the past 4 years between 2016 to 2019. The data set contains the information of total accident due to weather like fog, rain, fine conditions. Here we have visualized the data because the visualization or a graphical representation of information makes it easier to identify patterns and outliers. In this graph, training loss and validation loss, we have done the training loss and validation loss using Adam optimizer and mean square error and epoching it. Learning curves are calculated from the training data set that gives an idea of how well the model is learning. In this graph, your learning curve has a high training loss at the beginning, which gradually decreases upon adding training loss, training values, and flattens gradually. Here, the number of training loss and validation loss moves to each other. Here, the curves are perfectly fitted for good accuracy. Next, presented by Vaishnavi.
Prediction of test and train of rain condition. Here we have predicted the previous data for analysis, how well the prediction is. Here taken the 3 values and predicted the 4th value. The iteration goes on till the end of the value. It's act like for loop. Here we have predicted the 2021 vehicle crash due to rainy condition. Predicted till month of May. The y-axis represent the total accident and the x-axis represent the days. The same here for a fine condition. X-axis represent the days and y-axis how the count of accident for 2021 May. Then we have predicted the total accident caused by rain, fog, and other climatic conditions. And conclusion, predicted the rain and fine vehicle crash accident of 2021 from Jan to May. Thank you, ma'am.
Could you go for your result and discussion slide?
Yes, ma'am.
From where you have these values of rain, fog, and fine weather condition? How you have got this figure?
We are just we have taken input from Mart, ma'am, and just visualized the parameters, ma'am.
You have taken from
Mart, ma'am.
It is a database.
Data set. Yes, ma'am.
It's a data set.
Yes, ma'am.
Okay, actually, I couldn't understand your project. Could you say in 3 to 4 lines?
ma'am, we have taken a data set of vehicle crash due to weather condition, ma'am. Like if rain, மழை வருது, மழை வரும்போது இவ்வளோ ஆக்சிடென்ட்ஸ் நடக்குது, ஃபாக்னால இவ்வளோ ஆக்சிடென்ட்ஸ் நடக்குது, சன்னி கண்டிஷன்னால இவ்வளோ ஆக்சிடென்ட் நடக்குது, அந்த மாதிரி டேட்டா செட் எடுத்து அதை ஃபியூச்சருக்கு ப்ரிடிக்ட் பண்ணுறோம் மேம். 2021 மே வரைக்கும் இவ்வளோ நடக்கும் அப்படின்னு சொல்லி ப்ரிடிக்ட் பண்ணுறோம் மேம்.
ஓகே. சரி, எப்படி என்னென்ன ஃபீச்சர்ஸ் எல்லாம் எடுத்துட்டு போறீங்க?
மேம் ரெய்னி
ஓகே, அதான் நான் கேட்குறேன். ஃபாக்னால ஒரு 25 ஆக்சிடென்ட்ஸ் நடக்குது, ரெய்னினால 15 ஆக்சிடென்ட்ஸ் நடக்குது அப்படின்றது உன்னோட டேட்டா செட்டு. இந்த 15 25 வச்சுட்டு எப்படி வந்து மே 2021 வரைக்கும் யூ ஹேவ் ப்ரெடிக்டட்?
மேம் 4 இயர்ஸ் டேட்டா எடுத்திருக்கோம் மேம்.
ஓகே,
1461 டேட்டாஸ் எடுத்திருக்கோம் மேம். அதை வச்சு 2020க்கு ப்ரெடிக்ட் பண்ணியிருக்கோம் மேம். அந்த ப்ரெடிக்ஷன் 360 டேஸ் எடுத்து மறுபடியும் ட்ரைன் பண்ணி டெஸ்ட் பண்ணி 2021க்கான ஒரு 6 மந்த் ப்ரெடிக்ட் பண்ணியிருக்கோம் மேம்.
அதுதான்ப்பா நான் சொல்றேன். அதாவது மார்ச் சரி, ஓகே, நீ மார்ச் 2000 சம்திங் மார்ச் 2005ல இருந்து எடுத்துக்கிட்டீங்கன்னு வச்சுக்கோங்க. மார்ச் 2005க்கு ஃபாக் ஒரு டேட்டா, ரெய்னி ஒரு டேட்டா, அந்த மாதிரி எடுத்துப்பீங்க. அந்த பர்டிகுலர் வேல்யூஸை மட்டும் வச்சுட்டு நீங்க எப்படி ட்ரைன் பண்ணீங்கன்னு கேக்குறேன். These are all numerical values, right? அந்த நியூமரிக்கல் வேல்யூஸ் கூட வேற ஏதாவது ஃபியூச்சர்ஸ் ஆட் பண்றீங்களா? இந்த 4 ஃபியூச்சர்ஸ் தானா? ஃபாக், ரெய்னி, ஃபைன் வெதர் கண்டிஷன், சன்னி கண்டிஷன், இந்த 4 தானா? இல்ல இந்த 4ஓட நியூமரிக்கல் வேல்யூஸ் 1 and 2 அத மட்டும் வச்சுட்டு எப்படி நீங்க வந்து டேட்டாவை ப்ரெடிக்ட் பண்ணுவீங்க அப்படின்னு கேக்குறேன்.
இப்போ ரெய்னின்னா ஒரு 100 இன்னைக்கு நடந்திருக்கு, நாளைக்கு 120 நடக்குது, அந்த மாதிரி எடுத்து பண்ணியிருக்கோம் மேம். நியூமரிக்கல் வேல்யூ தான் மேம்.
ஓகே ஓகே, நோ क्वेश्चन.
ஓகே.
Excuse me. Am I audible?
Yes.
Have you predicted due to rain only this much accident is there? Due to sunny conditions, this many accidents are there. Have you predicted like this for 2021?
Yes, ma'am. Yes, ma'am. We are predicted for that, like that, ma'am. For
What
each
is that? Okay. What is it? Whether you have observed any error compared to the previous case? 2021 mostly 4 months has over.
Yes, ma'am. We till May we have predicted, ma'am.
Okay, 4 months have gone. Now we are in 4th month.
Yes, ma'am.
Whether the thing what you have predicted is the same as the one what we have observed now?
மேம் அது தெரியாது இல்லை மேம். இன்னும் வெஹிக்கிள்னால கிராஷ் நடந்தது, இன்னும் அப்டேட் ஆகலை இல்லை மேம்.
So how can you say that your thing what you have predicted is correct? You have given on some random number, you have given on a random chart. How we can, how you are saying that what the thing you have given is right? Already 3 months have gone.
Yes,
but we could not able to justify your result.
Ma'am, we have just predicted analyzed for past year, ma'am. 2020 we have just analyzed how well it came.
Okay, whether have you got the data set for 2020 in your marks database?
No, ma'am. No, 2019 till 2019 I have got.
Okay, have you checked it from the previous data from 16 to 18 with 3 years database? Have you verified your prediction value for 2019?
Yes, ma'am. Checked. We are not plotted the graph. We have checked with the values, ma'am. Just compared with values. How for day 1 2019, what is the value and what is the predicted output? We have checked with value.
Whether you have got the accurate result for both the case, both the value whether gets matched.
Little ups and downs are there, ma'am.
What is that error?
It shows 10 values low than what is the actual value.
What is the percentage of error? You tell it in percentage. Accuracy, how? What is that percentage of accuracy otherwise?
90% it shows accuracy, ma'am.
Really, have you calculated it?
No, ma'am, we have calculated the error, ma'am. We are not calculated the accuracy, we have calculated error, ma'am.
Error it comes around 10% or 20%.
Almost similar, ma'am. 10%.
Try to calculate the accuracy and percentage of error before coming to next presentation. Okay.
Okay.
Okay. Thank you.
Thank you.
Over to MOC.
Vaishnavi and the team, kindly turn on your video. The other two batchmates, kindly turn on your video.
Ma'am, I can't enable, ma'am.
Okay, that's okay. The participants, kindly don't leave the meeting. Stay till the end to capture the screenshot. Now I call upon Gokul B and his teammates from KS Rangasamy College of Technology to present the paper.
He is not here, Nandini.
Ma'am, then that's all, ma'am. All of us completed, ma'am. 3 batches are missing, ma'am.
Whether anybody is here that they have to present it? Whether anybody here have to present your paper?
Ma'am, someone, Hemapriya, has joined as guest, ma'am. We have not presented still, ma'am.
Okay, we'll check it. Whether anybody is here to present? You just call their names and the first 2 batches.
Yes, ma'am. Arun Kumar M. Ma'am, actually, he is not in the meeting, ma'am.
He is not here? Then
no. Then Dinesh
okay,
Kumar
next.
LD.
No, he is also not here.
Ma'am, that's all, ma'am.
Okay, second batch?
Ma'am,
only the 2 names you are having.
Yes, ma'am.
Okay. So all of the batches, those who have joined here, I think you have presented it. So we can end this meeting. Further information will be intimated to you through your mail. Okay. We can leave this session. Thank you.
Ma'am, once again,
yes.
ma'am. The participants and the juries are requested to turn on your video so that we could capture the moment. Participants, kindly turn on your video.
Vaishnavi, Vivipriya, turn on your video. Tirumurti, Shah, Ugalavan, Nagapriya, if you are here, turn on your video. Tirumurti. Okay.
Thank you. We thank the jury members and all the participants for making this event a successful one. The session is officially ended.
Okay, thank you all of you.